Okay, guys, and so sorry I'm not there today. My little boy woke up sick this morning, so this is kind of a quick absence. Let me tell you how this week's going to go because it's going to be an unusual week. I will not be at school Thursday and Friday because of a conference I'm going to in Austin. I will not be in school tomorrow morning because I have a dentist appointment, and today was an unplanned absence. So if you're in first or second period, you're not going to see me this week at all. If you are in fifth, sixth, and seventh, you'll see me tomorrow afternoon, and that will be it. So this is going to be a little bit different week. We'll kind of be doing things similar to this, where I'm going to be teaching you via a recording. The lab that we're going to do today, we'll push that back. We'll probably end up doing that next Monday. You did good job preparation on it. We're not going to throw that aside. We are going to do that lab, and so just be patient, and we'll get to it. You did a good job preparing for it. This is going to go fast. I have to talk fast because I'm limited to 15 minutes and I want to get a lot done today. And so you might need to pause and rewind. That's going to be just fine. If you as a class need to do it, or if you want to watch it as a class and then go to the computers and watch it again as an individual, that's okay as well. But just be aware that I'm going to be talking very fast and moving very quickly through this. So you might want to pause right now. Go ahead and get out a notebook because you need to take some notes on this. I'm going to go ahead and proceed as if you've paused and are ready to go. And so, what is this unit about? This unit is about matter and its properties. And so, a lot of this is going to be review. I'm going to go very quickly through what I think should be review for you, and then we'll slow down a little bit when we get to new stuff. You should know what matter is. Matter is anything that has mass and takes up space. And so if you look in these pictures, you see matter. Pretty much anything that you see in here is matter. The water, the beach, the people, the trees, the leaves, the sand, even the clouds and the sky, the mountains in the background, the trees over here, the rock, the cloud. It's all matter. Anything that has mass and takes up space is matter. I like to throw out there what's not matter. If all this stuff that we see is matter, what would not be matter? And typically, the only things that would not be matter are some forms of energy. And some forms of energy are matter. Like, for example, you could argue like light is matter because one duality nature of light has photons, and photons would have mass and take up space. And so it just depends on what kind of energy you're talking about. But some people will classify some forms of energy as non-matter. That is matter. Matter has mass and space in the definition, so let's talk about those. What's the definition of mass? Mass is anything that has, or is a measure of how much matter an object has. And so it's kind of a circular definition between matter and mass, but it's the way it is. So if you have a little bit of matter, you would have a little bit of mass. If you have a lot of matter, you would have a lot of mass. It just depends on how much matter you have as to how much mass you have. Space is a measure of volume, and so how much space something occupies is a measure of its volume. You're very familiar with that. What about weight? Let's throw weight out there. Is weight the same thing as mass? You should know this, and the answer is no, it's not. Weight is the effect of the pull of gravity on a mass. It's not dependent upon. Sorry, I had a little disruption there. Weight is the effect of the pull of gravity on a mass. And so if you hop on a spaceship and go out into space, your weight will change, but your mass will not change. And so that's just what weight is. It's gravity pulling on something. The more gravity, the more it will pull, the more the weight. So we can go to Jupiter, which has much more gravitational pull than Earth, and we would weigh more, but our mass didn't change. Or we go to the moon, which has less gravity, and we'll weigh less, but our mass didn't change. And so that's just the difference between what mass is and what weight is. We're going to talk about some properties of matter. The first ones we're going to talk about are extensive properties and intensive properties. Extensive properties depend on how much of the object or substance you have. Intensive properties do not depend on how much of the substance or item you have. And so, for example, here's a glass of milk. And so, what about this milk would depend on how much you have? Well, a couple of easy ones would be volume and mass. If you have more milk, you have more volume. It changes. If you have more milk, you have more mass. It changes. So the mass changes and the volume changes based on how much you have. that makes it extensive. That's external to the item itself. It depends on how much of the item you have. Contrast that with intensive properties. It doesn't matter how much you have. And so looking at this glass of milk, what would not change whether you had a little bit or a lot? Well, something that's very obvious should be the color. It will be white whether you have a little bit of milk or a lot of milk. Density would not change whether you have a little bit or a lot. If you have more of it, you would have more mass, but you would also have more volume, and that ratio of mass to density would remain constant. So the density would stay the same. The taste would stay the same. And so things that don't change when you have different amounts of it are intensive. They are internal to the object. It's a character of the object itself. And so that's the difference between extensive and intensive. And I think you've probably been taught that before in the past. But if not, there you go. Physical properties of matter. Let's talk about that. You should know this. My fifth grade daughter came home learning this word the other day out of her science class. A property of matter that can be observed or measured without changing the identity of the substance. And so that's the key here. We're not going to change the identity. The identity is constant. Something that we can observe or measure. Typically, you use your 5 senses to observe physical properties of matter. And so examples of physical properties are color, density, melting point, freezing point, solubility. So we can look at these pieces of metal here and we can observe some physical properties. Some of them have different colors. We don't change it by observing the color. We could measure its volume and its mass and calculate out its density. We don't change it by doing that. We could melt it. And that one can be confusing sometimes. You're like, but you're changing it. But no, if I took this is a piece of copper right here. If I took this piece of copper and melted it, what would I have? Well, I would still have copper. It would just be liquid copper. So I could determine the melting point by melting it, but I didn't change the identity. The identity is still copper. I may have changed the substance in some way, but I didn't change what it is. Solubility is another one that we could do. So these are physical properties. Properties that can be observed or measured without changing the identity of the substance are physical properties. Physical changes, on the other hand, would be a change that alters the substance in some way. So the substance is changed in some way, but the identity still remains the same. And so examples of this would be tearing or cutting, or state changes like boiling and freezing and melting, for example. If I melt that copper, I changed the copper, but I didn't change what it is. So that would be a physical change. Dissolving, that one can be a confusing one sometimes. You throw some sugar in water and you're like, oh, but it's gone. I changed it. It's not there anymore. No, the sugar is still there. It just changed its form, but it's still sugar. How do you know? Taste whatever you put the sugar into. You still taste the sugar. The sugar is there. You just no longer see it anymore. It's in a dissolved state. So those are physical changes. So a physical change, again, it changes the substance in some way, but it doesn't change what the substance is. So I could tear a piece of paper. It's still paper. I made a change to the paper, but it's still paper. So some examples here. This is boiling. I mean, so we have water here. It's boiling. This is liquid. This is a vaporized water. It's steam. It's still water, though. Dissolving. This is an antacid or something, and it's dissolving. Well, that antacid will be in the liquid when it's dissolved. It has just changed its form. That's a physical change. This would be sanding. He's sanding this piece of wood. Well, the wood's being changed, but it's still a piece of wood. Melting. So this is ice, solid water, frozen water. It melts. It's changing. The substance is changing, but you still have liquid water here. And so it's still the same substance. So these are all examples of physical changes. What about chemical properties? So we had physical properties and chemical and physical changes. We also have chemical properties and chemical changes. Well, chemical properties are the ability of a substance to undergo a chemical reaction and form a new substance. A new substance is formed, the identity changes, the very nature of the substance has changed. It has become a new thing. That is a chemical property. Chemical property is the ability to do this. It doesn't have to do it. It just has to have the ability to do it. So for example, an iron nail or a car, an older car made of iron or steel, can combine with oxygen to form rust. Rusting is a process called oxidation. Iron can rust. It has the ability to rust. If it's kept inside in a dry environment, it will not rust, but it can rust. It has that ability. And so iron has the ability to oxidize. That is a chemical property of iron. Other examples of chemical properties would be combustion, the ability to combust, which is burning, the ability to decompose, the ability to ferment, the ability to corrode. These are other examples of chemical properties. In any and all of those, something new is created. One substance or compound is converted into another substance or compound. The very nature of the substance changes. Chemical changes are the same things as chemical properties. It's just those things are actually happening. And so you take that nice new shiny iron nail and you put it outside in a wet, damp environment with oxygen, and it's going to begin to oxidize, a slow process of oxidation. And so that would be the chemical change. So it's just when a property actually happens, we have a chemical change. These chemical changes are known as chemical reactions, which is what chemistry is all about, is all these chemical reactions that we're going to learn about and have fun understanding how those things work. So let's look. Again, well, one more substance is changed to a new substance. Let's look at some examples of chemical changes. So cooking, you may not realize it, but cooking is almost always, almost exclusively going to be a chemical change. The substances are being changed. We're heating them. We're not just making them hot, but the heat is causing chemical reactions to occur. For example, when you cook this egg, the egg white in particular starts out clear. It changes into something new that is white. That's a new substance. The proteins are denatured as it's cooking. Here's some examples of iron screws and nails and bolts and things like that. And you can see on here they're rusting. So those are examples of chemical changes. Burning, and so this piece of wood is going to change. It's going to be black and charred after the reaction has occurred. And so it's a new substance. It would not burn again. The chemical property changes because the physical properties and chemical properties will change. New colors, new densities, no longer can burn because it has already burned, since it's a new substance that's not combustible. The changing of leaves in the fall, that's a chemical reaction that is occurring. The chlorophyll, which is green, is decomposing, leaving behind other chemicals, keratin, and there's another one, I forget what it's called, that have different colors, and so those colors begin to show through. The chlorophyll usually masks those colors because of its strength in the leaves, but in the fall that chlorophyll disappears, allowing the other colors to come through. And then here's a chemical reaction. Nice, pretty color change occurring as a new substance is created. When these two clear liquids are poured together, a bright yellow substance is created instantaneously. And so those are chemical changes. Okay, so what are you going to do today? You should have a stack of paper, some handouts in the class that should have been copied off by one of the other teachers. And it's just going to kind of go through this stuff that we just went through very quickly. And so I want you to answer those questions to the best of your ability. If you need to review this little video, just hop over to a computer or use an iPad or something and watch it again. Don't be visiting Facebook. Don't be visiting other sites. But if you need to view the video again, it's on my Google site. And so we'll do something like this tomorrow. Go ahead and bring Napoleon's Buttons, the book, to class each day this week. One day I'm probably going to have you read chapter 1 and do a response. I'll give you class time to do. You're just reading in class. So bring that each day. I haven't decided which day I'm going to do that. And it'll probably be either tomorrow or Friday, but I haven't decided yet. So make sure you bring it to school for the next few days because you're going to use it one day. Have a good day, guys, and we'll see you in a few days.